All right, and welcome. Here we go. Cumulative review number 16. We're going to rock this puppy. We're going to dial this one in. We're going to dial it in. Let's dial it in. Okay, so we'll dial it in here. Okay, let's go. We're going to dial it in. Let's dial it in to number 1. All right, number 1, given the following sequence. Okay, I'm going from negative 25, negative 35, negative 45, negative, and so on and so forth. What's happening? What am I doing? Oh, I am subtracting 10 every single time. So to find my next, I subtract 10 and get negative 75. My next one after that, negative 85, negative 95. Okay? Write the recursive formula. Okay, remember recursive means that I'm going to use the previous term to help me find my next term. So in this case, I'm going to use my first term, which is negative 25, to help me find my second term. Well, what do I do with my first term to get to my second term? I subtract 10. So my general case will be a sub n minus 10. Alright? This is the laptop that gets me frustrated, so if I get frustrated, it's totally normal. Don't you worry. Well, here we go. So write the general term or explicit term, alright, the nth term equation. All of these mean the same thing. What they mean is we're going to use our nth term of our arithmetic sequence. And I know that this is arithmetic, and I know to use this one because there is a common difference. I subtract 10 every single time. That means my common difference is negative 10. Leave the n minus 1. My first term is right here. Negative 25 equals a sub n. Distribute negative 10n plus 10, and then negative 25 comes down for the ride. Combine my like terms, I get negative 10n minus 15. Wow! That's my general term, my explicit term, my nth term equation. Let's dial in for part D. Here we go. Find the sum of the first 40 terms of the previous sequence. Use a formula. So, again, we're dealing with arithmetic. The arithmetic sum formula, see, there it goes. Chill out, dude. S sub n equals n over 2 times a1 plus a n. Boom. Well, how many terms am I finding the sum of? 40. So that means n, wherever you see an n, I put a 40. So S of 40 equals 40 over 2 times, my first term is negative 25, plus a 40. Now, it's not a sub n, it's a sub 40, because anytime we're finding the sum of the first 40 terms, anytime I see an n, I put in 40. Well, do I know what my 40th term is? No, I do not. So I have to use this equation in red. Notice how I put them all in red for you. Wow, the color coordination is off the chain. Holy buckets. Alright, so now, oh well, like there's someone right next door to me. They're like, who is this crazy person talking to himself? Okay, so I find the 40th term. Negative 10 times 40 minus 15. It's already aggravating. So, negative 10 times 40 is negative 400. Minus 15 gives me negative 415. So now instead of a sub 40, I have negative 415. So I can do this 20 times negative 25 plus negative 415. Now, some of us, what are we going to do? We're going to distribute the 20. But remember, order of operations, PEMDAS says I should do whatever's in the parentheses first. I should add these two together. Okay, add these two together to give negative 440, and then multiply it by 20. So your sum should be negative 8,800. That's what your sum should be. That's a 0, not a 6. All right. Let's go to number 2. Number 2, okay, subtract 300, subtract 75. So there's not a common difference. All right. So that tells me that this potentially could be arithmetic, meaning there could be a common ratio, meaning I'm dividing or multiplying by some number every single time. But what am I doing here? I'm really dividing by 4. So I divide by 4, or I multiply by 1/4 times 1/4 times 1/4. Let's do a little star then. Times 1/4. Alright, so if I multiply by 1/4 or divide by 4, that should be 25 over 16. My next term after that should be 25 over 64. And after that should be 25 over 256. Okay? My first term, 400. Recursive, remember I'm using the previous term to help me find my next term. So my previous term is a sub. So you can write this two ways. You can write it as 1/4 times a sub n, or you could write it as a sub n over 4. Okay, I mean, we would accept either one, really, or at least we would accept either one. Okay, but if I do it like this, it's going to help me finding my nth term equation. Because remember, the nth term, the general term, the explicit term, for a geometric is a sub, that's an a, sub n equals, oh my goodness, a1 times my common ratio to the n minus 1. There it is. Alright, so a sub n, my first term, is 400 times my common ratio. This is why I did 1/4, because the common ratio is 1/4 to the n minus 1. Now I could say divide by 4, but that's the same thing, right? So find the sum of the first 15 terms. Okay? Use the formula. Alright? So our general formula for sum is S sub n equals a1 times 1 minus r to the n all over 1 minus r. So I'm finding, let's make that blue. Blue, okay. So I'm finding here, remember what I said on the last one. It says 15 terms. Therefore, anywhere you see an n, you plug in 15. So it becomes S sub 15. That's a 15. Okay, just go with it. S sub 15 equals the first term, which is 400. 1 minus my common ratio is 1/4 to the 15th power. And make sure you're doing what's in parentheses first. Okay? I want to do my exponents. 1/4 or 0.25 to the 15, and do 1 minus that answer, and then multiply it by 400, and then divide it by this, 0.75, and you should get 533.33. It was like 3. I think it was like 334. Excuse me. Excuse me. Maybe like 335 or something like that. Okay. Yeah, sorry. Next one. Here we go. I just rounded to 3, 3. Maybe 3, 2, 5. That's right, 3, 2, 5. Duh. All right, so next one. Find the infinite sum of the sequence. Infinite sum means I'm going to use geometric. All right, the infinite geometric sum is a1 over 1 minus r. Okay, so our sum is going to be 400 over 1 minus 1/4, or in other terms, 400 divided by 0.75, which is, it just so happens to be about the same. Is that always going to happen? No. Do not assume that it's going to happen. All right. Why is it possible to find the infinite sum of this sequence? What is unique about the common ratio? Well, the reason we're able to find the infinite sum is because it's between 1 and -1, or -1 and 1. It's a fraction. It is 1 over 4. It is 1/2. It is 1/5. All right. Those not, when our ratio is like that, then I can find the infinite sum. If not, then I'm not sure what happened there. I just stopped recording. Sorry. Then I cannot. Okay. Because our infinite sum, because our ratio between 1 and -1, the common ratio, then that means I can find that infinite sum. Alright? There's no chance I'm going to finish this in 4 minutes. Is there? Now 3. No. Okay, so I'm just going to stop it here, okay, and then we're going to pick it back up on the next one.